in our supply chain, it is source, make, transport or send, then sell, right? So those are SMSS: source, make, then send, sell. Supply chain analytics. We are covering today the second step of supply chain analytics on the production or make side. So what kind of analytics you can run on production when either in assembly line or a process industry, right? Wherever it is, what kind of analytics we can run? It can be again simple descriptive. So we might have a data visualization or a simple reporting tool, maybe a simple Excel also, not need not be always Tableau or Power BI or QuickSense. It can be as simple as a Excel dashboard, which just gets those plant report or production report CSV files and continuously update that. So for the last 1 week, we are observing that the daily actual production volume is 15% below target, right? So without visiting anywhere, right? Without getting into the form, like 100 pages of report, the plant manager sitting on his desk will be able to understand there is actually a 15% reduction if I compare to last week or last month, right? Then again, you will dig deep, right? Why that 15% reduction in production has happened? Whether there was something plant shutdown or plant maintenance, or it is something which like emergency shutdown has happened, or some raw material has not come, right? So that is where you descriptive, as you are visualizing something, right? Then diagnostic. If the problem is happening, right, then you will carry out a root cause analysis. So I have this plant on this, out of 10 assembly line, this assembly number 8 is having issue for last 3 months intermittently. For few months it will work fine, then suddenly 1 month there will be reduction in performance, right? So now you are digging little bit deep, right? Then drill down opportunities, identifying dependencies, identifying patterns. Is this happening one time, or that for last 3 years or 5 years? Particularly winter months or summer months or rainy months, there is a particular problem in certain assembly line. Then you will be able to know that, okay, particular month or particular week, maybe it is a issue with your workforce. During certain shifts, only those issues are happening. There is nothing wrong with the assembly line. There is nothing wrong with the equipment. Particular employees, they are not kind of following the processes and issues are happening, right? So that is where you will have a lot of data where you will get through, dig down, drill down and find out that why it is happening. You are diagnosing the situation. Then predictive, right? So if I have the past data, am I able to predict something for the future? If I have the supplier data and I know that these are the few suppliers which generally, if winter month there is a delay in supply. So for I have the data for past 5 years or 10 years, every weekly, every day data, right? Then I'll be able to predict. Yes, particularly when this January or February month starts, this there will be a delay in supply from this particular 3 or 5 suppliers. So this is something which I'm predicting, right? I have the data. So then what will happen? Before the delay, I'll send them an email saying that last 2 years you have been delaying. Make sure that there is no delay. If there is a delay, I'll put a penalty clause, right? Or if I know that there is no way around, they will anyhow delay. So I'll have to have a backup plan because I cannot keep my plant idle, right? So that is where the predictive part comes into picture. Then the prescriptive part. Prescriptive analytics is something, if I have 3 4 solution, which solution at this point of time, like think about prescriptive, always remember a kind of analogy of a doctor. If I go to a doctor and I say that, okay, there is a pain in my chest, I am difficulty in breathing. So there can be hundred of scenarios, right? Difficulty in breathing might arise due to hundred of scenarios, but due to doctor's experience and the current scenario, he will prescribe me something, right? Okay, do this test. If this comes positive, then do this, right? So this is the prescription, right? Because he is not going to tell me, okay, do 100 tests. Obviously, if nothing comes out, he will keep doing that. But ideally, you will have something in mind. Out of those 100 scenarios, these are the 3 or 5 scenarios, which, because for a person at the age group of from this to this, if a sedentary lifestyle, these are the scenarios, right? So he has certain prescriptions, right? And he is prescribing that. okay, if do this test, if this happens, then we will carry out this kind of whatever, maybe exercise or maybe some kind of medicines and all those things, right? Or it can be due to COVID also, right? Nobody knows. So these are the few scenarios based on his experience, based on his current situation. He will be able to prescribe certain treatment. Same thing here. I might have hundred of regions for which the equipment is failing, or the kind of my resources are not working in the optimized way. Out of that, based on my previous experience, so here what is the experience? The information what I have. Last year or last to last year, whenever these kind of issues happened, we had carried out this kind of diagnostics and this kind of solutions work better way, right? So here I am prescribing something, right? So this also can be done in another example, can be when we will do it the simulation. So example I was giving, right? So I have three plants and I will have different cost. There is something the like fixed cost, there is certain overhead cost, right? Variable cost. Then there will be raw material cost, there will be transportation cost, right? So there are different combination, different products. So which kind of products would be manufactured at what plant, right? So if I have to take that kind of decision, I have to prescribe those kind of solution. So that is something where the prescriptive analytics comes into picture. Think about HUL. HUL might have 8 to 10 different factories, different manufacturing process plants across India. So and they have around, I don't know, maybe 30,000 or 50,000 this stock keeping units, right? So how do they decide these units or this kind of material will be manufactured in this plant, right? So that is somewhere they can prescribe. Whenever a new product comes, how will they decide where to manufacture that product, right? So they will have different parameters. Based on that, the algorithm will run and give a optimized solution. So that is something known as the prescriptive analytics. So specifically how to put it, like I said, we'll discuss when we run those simulations later on, maybe after 3 or 4 sessions, we'll come to know that actually how to run and find out those optimized solutions. So we are going to discuss some of this, how to achieve. So supply chain analytics, risk management, this we discussed actually in the last class, right? Sourcing analytics, vendor evaluation, strategic risk management, which is a part of your strategic sourcing. Find out which are the items which are critical in nature. Accordingly, take a step towards it. I have a risk management plan. Then there is production and operational efficiency. There are various ways to achieve those kind of operational efficiency. Then demand planning, forecasting. We are not going to discuss today the forecasting techniques. We'll discuss later on. But remember that that is something which we need to discuss, and specifically in the plant manufacturing scenario. Then this is overheads and labor cost tracking, which is basically workforce analytics. Because most of the manufacturing plant, which is not, none of them I don't think is 100% automated, right? There will be always human workers, right? So what will be the optimized combination of robots and automation and humans? So if human workers are working, how many shifts they should work, right? And that is a big problem. If you see, if some of you understand all this, how these government companies work, one of the major kind of salary chunk or the major income source for those employees who work in government plants or manufacturing plant is the overtime. Once your shift is over, if you're doing a 6 hours or 8 hours of shift, so you get around 1.5 times or 2 times of your whatever per day daily rate, right? And that is where the actual delay happens, because if they know that they're doing overtime, they're going to get additional salary. But just imagine yourself as a plant manager. Your objective is to reduce cost, reduce the overall cost of production. And how to manage that? It is not only about the analytics, it is about the industrial resource management also. Your HR initiatives has to come into picture. If I just say that no, you have to, I have done analytics and come to know that this work need to be completed within 10 minutes, why you are delaying it and taking 30 minutes? Tomorrow there will be a strike in your assembly line or strike in your production plant. So this is somewhere, remember always, Along with your number crunching, your person or people skills also has to come into picture. Sometimes you have to remember it is not only about the numbers. How to manage those people based on the whatever results you are getting is a kind of difficult task, and mostly for this kind of production or plant managers. So different type of manufacturing analytics. So cost, how much wastage is happening, inventory turns, value added analysis, cost productivity. There is something called value analysis and value engineering, right? So most of the manufacturing companies, whether automobile, any kind of manufacturing companies, one of the major aim in production and purchasing is how to keep on reducing the cost of goods sold. So they keep on benchmarking their product with new technology, new competitors, or not new competitors, the existing competitors, right? So that is somewhere the product breakdown happens every now and then. So you compare cost, like even the smallest part of a machine, what is the cost, whatever the production cost for me, and what is the production cost for a this your competitor. So there is actually a Ariba software that license itself cost around 10 lakhs. Specific license which you can do this value analysis and value engineering, VEA. That is a costly license, because what happens, so they have the, so if I put a, like let's say I want to produce a nut and bolt, or I want to produce a plastic frame which will be useful for a MI phone. If I give the dimension, if I give the raw material, and if I give the location also, so it will be able to tell me what will be the cost. I need not have to do anything, because they collect data. They have a huge database, location wise, industry wise, workforce wise, raw material wise. All the cost information is inbuilt into that software. Once I put my numbers, okay, I want to manufacture this bottle, okay, this cap, this bottle, whatever is the, like let's say I want to manufacture this bottle. If I give the dimension, color, raw material, what kind of raw material, even the this labels, all those things, and I put I want to produce in India, maybe in Mumbai plant, or maybe in Gurgaon plant, it will be able to give me a, obviously it cannot be 100% exact, but within a range of plus minus 15%, what will be the cost of that, the production of that bottle. So that software license is actually very costly. I think per person license was 10 lakhs per year. Lead times, cycle time, then setup times, material availability, machine uptime, customer service time. So this is where our end goal is to send our material out of the plant to distributor or retailer, and from there to the customer, right? If there is some delay in our case, right, obviously the customer service time will be affected. Same thing with the machine uptime. Uptime means how much time in a year or in a month machine is running. So there are no shutdown, or it is not like kind of in maintenance. Material availability, it is much to do with the production planning and your procurement division. Setup times, setup times means how much time it takes ready to set up your machines. Every time, every day before the assembly starts, right? So there will be a process check, setup of machines, starting of the power, checking that all the safety drills has been done. It takes around, for 8 hours shift, maybe half an hour or 20 minutes it takes for a setup time for each of those machines. So whether there is a increase in setup time, right, or decrease, is there any way we can decrease that? Cycle time is the time it takes to manufacture a product, right, depending upon my customer requirement. Production quality, vendor quality, production quality, data accuracy, cost of quality, right? So this is a big problem, data accuracy, right? Because most of the times, even if you take the biggest plants, right, the entry is manual. What you are keeping or what you are entering. So there will be like a resource person in the plant, and that is not their work, right? So they will be working on assembly line. Additional work is to input all those details, how many raw materials came, what was the production time, everything. If it is automated, it is very good, all things being captured automatically. But manual intervention when happens, there is a problem with your data accuracy. So what happens, plant manager not knowing that data are inaccurate is still working on those numbers which will give them wrong insights. Then reliability, vendor delivery performance. So this is something which was predicting, right? If I understand that for the last 5 quarters a vendor is delaying in particular week, in a month, particular days, there will be delay in order, delay in supplying material. So I should be able to predict that now and should initiate certain actions. Either should take certain actions against the vendor or do certain preventive actions. In case there is a delay, what to do? What kind of backup I have? Schedule adherence, order and schedule changes, lost sales, right? Lost sales generally happens due to backorder. If there is a requirement from customer and your plant is not ready, you do not have inventory, right? So that is something the concept of back order comes, right? You are not able to supply that order at that point of time, right? So that order will be supplied or fulfilled in a later time, right? So what kind of data? There will be certain enterprise data, there will be some operational data, right? Operational data is basically from your how the machine is running, how many raw material processed, right? Is there any issue log, right? Whenever a problem happens in a machine. So this is how the assembly line works, or the in a process industry, processes go on. So there will be issue log which will be giving, okay, if there was a trigger, there was a problem with these kind of machines. There will be enterprise data, which is basically your vendor data, your workforce data, which employees particularly in shift number. Let's say I want to understand who are the 50 employees who are working on Monday shift, next Monday shift, right? Those are the enterprise data. Details of employees, detail of shifts are already there, right? Then there will be transaction data, right? Transaction data can be in between like your vendors, suppliers, in between your different assembly lines also, right? How many like products moved from this plant A to plant B, right? So there are various way to process data, right? Batch data processing. So whenever you are looking into the dashboards, it is not that somebody will be sitting in front of a dashboard. Okay, what was the production today, right? Or what was the production last week, right? So the refresh rate of data. So it will be batch processed. So towards the end of that shift or towards the end of the day, whatever information. So it is basically think about the how what is the frequency of refreshing your dashboard, right? It is not that every 5 minutes the data need to be refreshed. So the all the data, all the information which accumulated on that day, all will be processed towards the end of the day. So tomorrow morning when the plant manager checks in 8 a.m., he will be able to refresh and find the new dashboard with all the details from yesterday, right? Because that is not that much critical, right? Because he is looking into weekly data, per day data, right? But there will be something departmental and operational apps, right? Which basically the shift leads will be holding, because they need to be aware of at each moment, each minute, each hour, their status in each assembly line, right? So there the frequency will be maybe half an hour, 15 minutes or 10 minutes. How frequently data is getting refreshed, because suddenly some issue happens in assembly line, that shift lead should be there, understanding why there is a problem, what issue happened, and he will be able to guide them, right? Then real-time alerts, stream data processing, right? Quickly, because think about the process line. A pipeline, crude oil is going to get processed. There is a leakage. So you cannot wait for 15 minutes, 30 minutes. It has to be real time in milliseconds, seconds, because if there is a leakage in, think about refinery pipelines where the crude oil are converted to petrol or diesel, the plant will get blasted, right? So that has to be asked. There is no, there should not be any delay in data processing. There is a error, and suddenly the those alerts, those lights should come up, red lights should come up, and everybody should stop the operations, right? So in a plant, you have to remember what is the importance of that data and how frequently that data need to be processed. Some data like the processes like pipeline where oil is moving, or assembly line where the some like kind of very hazardous materials are going, you need to be extra careful there. So there it not be that okay, some issue emergence happened and you come to know after 15 minutes. Every second, every minute is important there. But in certain cases, if where assembly line work is happening, issue every 15 minutes or 10 minutes. If there is a delay, 15 minutes frequency or half an hour frequency is also okay, because within that time shift lead will come and try to find a solution to the issue. Dashboards, which are basically you are looking for a weekly, monthly, or 6 monthly or quarterly data, right? So in that case, it is not that emergency of nature, right? So even if every day or every week it get refreshed, it is okay, right? Every company also will have their own kind of pattern of refreshing those data, right? So this is where you have to understand what is the frequency of data refresh, how that data is being processed. And any questions up to this point?
So can you repeat this departmental or operational apps?
Yeah, so any if you have visited any manufacturing plant, right now anyhow each one of them have mobile phone. Earlier those Kanban used to be there. So they'll put a red flag or a yellow flag, right? Any assembly line there is a problem, they'll put those flags. But right now everybody carrying a mobile phone, or they used to carry those handhold devices, right? So what happens, just think about a Maruti assembly line. So the plant, across plant, there will be 50 or 60 assembly line running, right? So there will be 50, 60 shift leads at any point of time. Particular assembly line, there is a issue, right? So it is a big manufacturing plant, right? You will not be possible to be every time standing in near the assembly line. So you will have a application which will be monitoring the status of assembly line, what is actually happening in assembly line. If let's say there is a machine problem, or there is a problem in certain raw material has not received, it will put a trigger, right? So this is how your data refresh is happening. Every 10 minutes or 15 minutes, the status check will happen. Okay, let's say each half an hour or 1 hour, we need to send cars from our process unit. So 8 cars at each 1 hour, 8 cars, let's say, need to be painted in that painting shop. So data refresh rate is 1 hour. So the information will be moving to the shift lead. So let's say there are in the first morning shift 8 a.m., 9 a.m. around already 8 cars have been painted. 10 a.m. 15 cars. Okay, so there was a shortage of 1 car. That means 1 car less has been painted. But by 11 a.m., suddenly it came down to 14 or 13. That means only 5 cars has been painted, right? So now what I mean, it will give you the yellow or red trigger in that application. So shift lead will come running away, looking into what issue is happening. Why our rate rather than 8 cars per hour, now only it is reduced to 5, right? So the data refresh rate might be each 1 hour your data is getting refreshed, and that find or getting updated how many cars were processed or how many cars were painted in that 1 hour. So data refresh rate will be like kind of a 1 hour, right? So again, like depending upon if it is a process unit, let's say you are processing a this whatever sugar or all this FMCG, whatever oil, their data frequency rate might be within 1 minute or within 3 minutes if there is a problem with process, because it is operating in a hydraulic or kind of compressors. If there is a problem, it will ultimately have a like problem with all your machines. So in that case, the data frequency of updating the processes, whether processes are operating properly or not, maybe 1 minute or 5 minutes, right? It will be very less. So those are the kind of departmental or operational apps.
Yes, sir. Thank you, sir.
So again, some repetition, predictive maintenance we can do, maximize critical asset, leveraging big data into predicted anticipate failures, right? If it is a critical item, right? For most of the assembly lines or the processing plants, compressor is a critical item because most of the machines run in compressed air. So should have a backup of compressors. If that compressor fails, repairing it might take 1 day or half a day, right? So you cannot stop your assembly line for that point of time. You should have a backup. You know there is a you are predicting that this compressor is showing problems and it might stop by tomorrow, right? Or it might show problems by tomorrow. So before it shows problem, your backup compressor will go, and when the shift ends, we'll put the backup compressor, and the existing compressor will go into the maintenance shop, right? So rather than waiting for when the problem will happen, you are predicting the maintenance schedule and accordingly managing that. Yield and throughput, basically again, each of the assembly line or process plant, right? Like I said, so we have a target to meet. Each hour we should produce this many kind of product, or this much quintal of sugar should be processed. When we understand, let's say there is a trigger, morning 9 a.m. or 10 a.m. trigger came that our production quantity of sugar has reduced from one processing plant from 1000 quintals to or 100 quintals to 80 quintal. So what kind of action you are going to take? Now to you have to recover because suddenly 80 quintal has happened. Whether you will increase, whether you will put additional labor, because you have to very quickly. So that is something is very critical in manufacturing plant. You have to take decision very quickly. What exactly you have to do so that your production, overall production doesn't hamper, right? Then system and supply chain operations. So this is basically like kind of what I was telling you before, right? So this is a little bit of prescriptive or predictive. So here, depending upon your sales mix, HUL or PNG, so they are into every SKU, right? Each product portfolio there, each product they might have 5 or 10 SKUs. What combination of items at what quantity at what plant need to be produced in each shift, that need to be kind of calculated, predicted, and accordingly plant schedule need to be prepared, because it cannot be done manually. Manually it will be impossible to conduct those kind of calculations. So it need to be, because again there are like many solutions. So just imagine if I have 1,000 of SKUs, 10,000 SKUs, 10 plants, 3 shifts each. Then there are distributors and warehouses. Then there are different sales mix. Each region will have a different requirement of different SKUs. So how to decide that which kind of SKU will be produced for next month at which plant, right? So that is where, or in the plant itself, which assembly line. So that decision need to be done through analytics, right? It is already established software is there. You just run those, put those numbers, and it will tell, it will divide. Again, there are you can think of n number of parameters. Workers might be on workers right now. COVID is happening. You will have a restriction or constraint on number of workers. So how to distribute your workers? How to distribute the shifts, right? Because there is a problem with HR also. It is not that I'll keep like one person will keep working 24 hours. So how the shift scheduling, the workforce analytics will happen. So everything has to come together. My production, it should not happen that one assembly line or the one machine is running for 24 hours. So I have to take care of that also. Machine should not run continuously more than 12 hours or 16 hours. That should be 2/3, 1/3. That means if they are running for 16 hours, that should be 8 hours rest, 8 hours of downtime. So how those combination will work, right? Then again is shipment, because if I have to supply something just in time, those suppliers who are supplying components to different automobile manufacturers, they have to decide how many trailers, how many trucks. So if you start doing calculation manually, you will never reach a solution, right? So all these things need to be put into algorithm, optimization algorithm, and it will give a optimal solution. Remember that whenever we are talking about prescriptive analytics or a optimization problem, there is no best solution. There won't, you will not able to find a best solution like we do some mathematics and say that this is the only solution. The point is you will have 5 or 10 solutions. Out of that, this is the one or two solutions which looks correct now, and accordingly you will go ahead with that. So for a chemical manufacturer, chemical industry, so this was a report from McKinsey. So they started doing analysis and try to find that which are the areas of analytics where they're adding much more value, right? So make and buy analytics, right? Make an ingredient instead of buying it. So that is a make and buy analytics. Shall I produce or manufacture this item, or shall I outsource this to a third party, where I should So out of, let's say, I'm thousand of components or hundreds of components. Out of that, how many I should actually manufacture in my assembly line, and how many I should outsource it to a third party. Sometimes outsourcing those work can be much more beneficial unless it is a patented technology. Substitute an ingredient in a more efficient production line and reduce material usage, right? So that is where your strategic sourcing comes into picture, right? Rather than using the earlier raw material, if you use a better raw material, better processing agent, so your waste will be reduced. So all these processing plant, uh, so there is a something called gross refining margin, right? So most of the refineries run or compared based on that. If you have a better technology like Reliance Jamnagar, though they are the newest refinery in India at one point of time, they had the highest gross refining margin. The money they are making out of that refinery, because the raw material they are using, the technology they are using, the equipment they are using were of the world class. So for that, what used to happen, the wastage was very less. Whereas the refineries from, let's say, Hindustan Petroleum or IOCL or BPCL, because they have been established 20 years or 30 years back. So the equipment was not optimized. Later on, that's why most of the refineries have put a lot of money, because unless you improve your refining margin, it will be loss making refinery. So they put a lot of investment. When I was there in HPCL, they put a 3,600 crore project just to improve the gross margin by one like kind of a 1 point. So I think we had at 6 point something. We wanted to make it 7.8 or something. Optimize inventory and planning, optimize equipment usage, reliability, gain incremental sales through increased production capacity, right? So this is a critical point, right? Rather than putting a new plant, which is a huge kind of a fixed cost, right? I need to have land, I need to have those permits, then I have to build my plant. With the same plant, if I can operate with higher efficiency, so that my production quantity can be higher, right? So that will give me much more benefit, right? That will give me increased sales. One example can be event failure, right? In your in the plant, you have the plant failure data, right? Which are the machines, which are the equipment have failed in the last 10 years, right? So now you can predict by running in this shift, which are the which are the components which potentially might fail. So I can put a logistics regression, put all the plant operation data, how many minutes they are running, how frequently they have maintained. All those will be independent variables. My dependent variable will be whether that equipment or that machine or that or whatever component might fail, will fail or not. If it fails, it is 1. If it is doesn't fail, it is operating perfectly, it is 0. That means it did not fail. So I can put a logistics regression. Logistics regression, as you know, answer will be 1 or 0. 1 means equipment is predicted to be failed, 0 means it will not fail. So if I can predict that whether that equipment or the component is going to fail, accordingly I can have a backup equipment for it or a backup components for that, right? Then there is something called digital twin, right? This is a new technology. The last 10 years it has been very popular. Think about a wind turbine. Actually, GE, I think GE is the first company which started. Not sure though, but I guess General Electric was the first company. So think about a asset, right? Wind turbine or a big kind of this your kind of submarines, all those things, like for the military, like let's say submarines, right? So what happens if the problem happens? Then only say, because I cannot have a person standing or nearby the wind turbine always, right? Wind turbine will be in the remote places. So the idea is, can I have a digital twin? Twin means what? Replica. Can I have a digital replica of that equipment? Let's say I have a wind turbine somewhere near the hilltop. I will have a model, right? 3D model on my laptop, and sensors will be put on that wind turbine, and the sensor data will be input into that 3D model. So what happens, how the wind turbine is performing, same thing my 3D model will be showing. Whenever there is a issue, my IoT sensor will be capturing that information, and so there will be problem will be showing in my 3D model. So I'll know that there might be issue with my actual whatever wind turbine, and I can send my team and they can do the predictive maintenance, right? Same thing for the F1 cars, right? F1 cars, they try to optimize the race, because they're like kind of racing at a like speed of 300 kilometers average speed, 250 kilometers or 300 kilometers per hour. So there is a problem with wind. There is a problem with anytime a driver tries to overtake. So what they do, they simulate all those things. But again, it is not only the simulation, because now what they do. So whenever that F1 driver is racing their car, a digital replica is running in your laptop. Same kind of your uh, racetrack, basically model of a racetrack, and your digital replica of that car is running. So what are the like parameters, all things will be captured, and accordingly you'll be able to optimize your car for the next race, right? So then how it is different from the simulation, right? Same thing, I can do a simulation in, so there are mechanical engineering, there are different softwares, right? CATIA, Autodesk, and all those things. I can build a simulation model and I can do all those analysis, right? Simulation generally happens in the static data. I've collected data, now I'm running a simulation and I'll come to know that where is the problem, right? I have the design data, running data. So simulation generally happens in the static data. Digital twin is basically for the dynamic data, real time data. Wind turbine is running, my and this wind turbine in my laptop, the model of the wind turbine is also running, right? Second part is the communication is two way. In the simulation part, what happens, I'm running my simulation in laptop, it has no impact on my wind turbine. But here what happens, if there is a problem, I can configure something in this here in my digital twin, and the same changes will be done in wind turbine. This General Electric's journalists are not General Electric, Rolls Royce. As you know that Rolls Royce do not sell those engines to Boeing or Airbus. They generally kind of rent them, right? And so what they sell is basically the not the engine. They sell how much uptime of that engine, right? So how will they ensure that engines are running properly? So they generally most of the times have these digital twins. Whenever a Airbus or a Boeing aircraft is taking into sky, flying in the sky, so they have a digital twin running on that control center. They have their own analytics team, and they will be studying those parameters, and they can predict, okay, this engine has kind of less performance, we need to have a predictive maintenance once they reach the destination. So with that, they are able to optimize the all the performance of those engines, right? So this, you remember, this is a very new and very kind of exciting concept in manufacturing and production, the concept of digital twin. Any questions or any doubt on this? Then the question about your, so we first discussed the production optimization, right? How to optimize your production assembly line through digital twin or through have a predictive maintenance, knowing when your equipment is going to fail, right? Then obviously we'll discuss about the human workforce analytics part. So that is one part. Talking about your machines through digital twin or through event failures, we're trying to manage the or predict maintenance activities. Second part is your raw material, which is in the plant. One part is to source it, right? That is under the sourcing analytics. Now, once your raw material in the plant or the manufacturing process, so the main idea is you should keep as minimum inventory as possible, right? Because inventory is cost. So your finance or your money is getting tired of your inventory. So the idea is as quickly you are able to produce the items and as quickly as you are able to sell those items, it is good for you, right? So that is the concept of inventory turnover. Inventory turnover means sales, let's say your annual sales. Then what is your average inventory, right? How will you calculate your average inventory? So there are very ways. If I am trying to calculate maybe the my last inventory, year end inventory, my year beginning inventory by 2, right? So that might be my average inventory, right? So what basically it shows that how many times in a year you are able to produce and sell those items. And for different industries, obviously it will be numbers will be different, right? For FMCG company, where the frequency of sales is maybe weekly or monthly or bi-weekly, inventory turnover has to be very high. Similarly, for automobile company, the inventory turnover little, so sorry, inventory turnover will be have to very low, right? Very quickly you are able to run it. Means how many times you are able to run it. But if you're there is a automobile company, right? Automobile company is selling a automobile. There was a study recently, right? Uh, so the idea was that in COVID there will be much more inventory, but they found out that obviously the region was production was not that much, but actually people bought much more cars, though they are not traveling anywhere, but they bought much more and mostly luxury cars, right? During this COVID period. So this is something called days of inventory by industry. Days of inventory is 365 divided by inventory turnover, right? So this is again old data till 2016. The question they are asking, ideally when we have this kind of so many tools, technologies to do analytics, right? Ideally your inventory days for inventory. That means how many days inventory stays in your plant, right? So here if you see aerospace defense 97, it got reduced slightly and suddenly it has increased, right? Beverage, your household product, basically FMCG products, 70 days on an average. 70 days means 2.5 months, right? All combined. Obviously some products will be less. Actually it has reduced to 63. So by 2016, if you see recent data, I could not find the data for recent years. Hopefully that would have reduced better. April retail, your clothes and all those things, 78, again 2.5 months. That has not changed much over the years. Pharmaceuticals, see the number, almost half a year, right? 180, 178 days. It is almost remaining in that range. So the question they are asking with this many analysts, so this is the amount of days, a number of days inventory stage in your plant or warehouse or retailer space. Basically, the idea is how quickly you are able to sell. So let's say I'll take whichever example. Let's say this one, household products, right? So if my days of inventory is 63, right? What will be inventory turnover? Let's say my days of inventory is 60, 63. What will be approximate uh, number of inventory turnover? Anyone? If my days inventory, the amount of time
Five.
inventory,
So 5.79.
yeah, close to 6, right? So what does
Yes.
6 means? That means for that industry, which is household products, let's say FMCG products, on an average, they're able to rotate their inventory turnover. How many rotations are happening, right? Inventory turns. 6 times they're able to rotate their inventory. That means 6 times they're able to produce and send. So once they produce, all the inventory gone. Second, they produce, almost all the inventory gone. So every 2 months, so they are able to sell their all the inventory, right? On an average, right? Some companies might have little bit higher, some companies might have little bit lower. So the as the number grows, just imagine if it is 12, that means each month you are able to produce and send all of your inventory. Then again the new production starts on an average, right? So as the number grows, it is better for you, right? For a company like Amazon, actually inventory turns because they are not producing most of the items. it comes and directly goes to the customer, right? So they, for them, inventory turns will be much more higher. But obviously it depends upon industry, right? I cannot compare that way. Automobile will have, or the manufacturing industry will have little bit of higher days in inventory. But the idea is, with this much analytics, still with this much information, with this much digitalization, there is a problem somewhere lying where we are not able to kind of basically reduce the days of inventory. If we are able to reduce the days of inventory, our inventory turns will improve, that will increase. So our intention is to increase inventory turnover. This number should increase, reduce this number, right? Any idea why with all this predictive analytics, big data, we are not able to do that? Any answer which comes to mind? Because we are talking a lot about analytics, but then why the results are not showing? If you see the food, for food industry, actually it has increased, though it is very slightly 4 days, but still on an average for a industry it is increasing. Any idea why it is the? One thing already we have discussed, that is the data integrity, data accuracy, right? When you talk about digitization, automation is will not happen automatically, right? There will be human intervention. What is the actual data, when they are putting those information correctly or not, right? So that is obviously data integrity is there. Second thing is about the number of SKUs has increased significantly, right? Once your number of SKUs, so think about in this way: number of soft drinks availability, number of whatever candies, number of food items which are available 20 years back in 2004 and 6, and now after around 18 years or 17 years, if I go and look into the number of options which are available, right, for the same company, number of items, number of SKUs they are producing. So once you start creating more number of SKUs, getting into this number will be very difficult, right? So there will be always increase or decrease in certain items depending upon the customization, depending upon the customer requirement, right? Think about apparel industry. The number of different fashion items, different kind of textures, different clothing items, different designs which are available has significantly changed over the last 10-15 years, right? Before also it was changed. Basically the idea is gradually the number of options which are providing to customers are increasing, right? So that is where the problem happens, right? When options are much, it is not necessarily that people will always take that same SKU. Just think about a small grocery shop. I have only one chocolate item. No matter what happens, whichever the best selling chocolate, I'll only keep that. So anybody comes, will take that. So I have only one box of chocolate, and that person, anybody comes, I'll have only one option, right? So if that is the only best selling item I'm keeping, I'll keep selling that. But generally what happens, I will have a collection of boxes, different chocolate items, right? People will keep, some boxes will be very quickly over, right? Some boxes will be still there. So as the number of options from a company increases, and just related to same analogy to a company, number of SKUs increase, number of items that company is selling increase, managing that becomes very difficult, even with the digitalization, even with all this data available, right? Because the once your option increases, customer has the, obviously different customers will have different choices, right? So meeting and matching that granular level of supply and demand becomes very difficult. Okay, produce 3 items only, produce 50 item of L size black color t-shirt with this caption, produce 60 items of long neck t-shirt v shape uh, or like some 42 size or something like that. So what happens, if I keep providing more options, managing the inventory becomes very difficult. But again, sales and marketing team will come back and say that unless you produce that, will not buy that. People are looking for those kind of items. And there is always a fight between this production and sales or marketing team. Sales and marketing will always look into how like kind of more customization they can do, right? How different items they can produce, how different offers or different choices they can give to their customers. But that becomes a problem for production plant, right? So that is where the balance has to happen in the sales integrated operation planning, where all of them has to come together and decide on which are the items are most they have to produce. Obviously there are different type of inventory: raw material, work in progress. Raw material is the what I'm getting from my suppliers, right? Components and all those things. Work in progress, which is in built, right? A car is in process, a car is being built, so that becomes a work in progress. Finished good, which is already completed production, quality check has happened and it is in my plant and will be sent to the go down or the warehouses, right? Then sometimes it will be in transit also, right? Different items at any point of time. If you see, when I talk about inventory, some items will be in my warehouses, some items will be in my plant, and some items also will be in the transit also, right? They also comprises of my inventory. What do you mean by MRO? What do you mean by MRO in production or operations? So MRO is maintenance, repair, and operations, right? So obviously for there are inventory for production. There will be obviously inventory for maintenance, repair, and operations, right? Think about a big plant. So many machines are running. So there will be spare parts for that machines. There will be spare oil, diesel or whichever it is running on. So there will be wares. All those items which is necessary for maintaining, repairing, and operation of those machines, right, or equipment. So those are inventory in terms of MRO inventory, right? This is actually helping me for production. This is not actual part of production, right? Think about any assembly line, right? So many machines are there, so many robots, so many automated machines are there. So how to like to operate them like kind of optimizedly in optimized way, we have to have those maintenance repair tools, right? We need to have those oils, we need to have those wires. So those are MRO inventory. Then whenever we talk about inventory, there are two concepts which are important for a production. Either I have excess inventory, that means I have produced and now sales people have told that you keep in your plant, whenever my distributor orders you send. So what happens, my space in the plant, it is like just taking space in my plant. I've already produced let's say 3000 cars. Out of that I have sent 2000 cars. 1000 cars are lying in my plant warehouse. It is taking a lot of space. So that is one situation where I have excess inventory, and it can be for the raw material also. It not necessarily finished good. Any of these can be excess inventory, right? Back order is when there is a requirement. So this is only for the finished good. Excess inventory can be of any kind. It can be of raw material, work in progress, finished goods, even MRO also. So I have got those items for spare parts and all those things, but it has been lying. It is not actually been in use. Back order is mostly for the finished goods. That means there is a requirement, there is a demand, but I do not have inventory for them. I have this much inventory. So I am not able to fulfill the customer's order at this point of time. So there will be back order placed in my production schedule. That means I have to produce that within next 1 month or 3 months so that I'll be able to meet the customer requirement, right? So any doubt on difference between back order and excess inventory? So the exercise which you need to complete by next week, and that is a group exercise. One person from the group need to upload the answer, is related to back order and excess inventory. Just after I complete the discussion, I'll first show you what is that assignment is about. So again, back order, that means there is a demand in market, right? So that is a good thing, right? Guaranteed demand for your production arm. So that is a good thing. Start a conversation with your customer. So whenever there is a back order, customer will request, like think about Amazon. Whenever there is a you need certain product and it shows that it is not available. So there is an option, right, where you say that whenever let me know whenever this product is available. So it is starting a conversation, right? So they might say that, okay, we do not have this book or this cloth. Why don't you look into the better item? So I was looking for a book. Later on, they gave me a send me a detail of a newer version or a edited version of that book, right? So that is where the conversation starts. Prepayments help cash flow. Sometimes if it is in huge demand, right? Look into your Royal Enfield, look into this new vehicles, Harley Davidson. Though Harley Davidson did not work that well in India, so there is always a back order. People will pay money. People will book those products for 6 months, 8 months, 10 months in advance. The same thing is happening currently for your Ola scooters. People have paid, I think, 499 rupees, and then that is a one of the greatest marketing trick, because see, the amount was so small. So everybody say, "Arey, I'll pay only 499." Because if you go and tell that to any scooter, like actual scooter, Chetak or Vespa and all those things, nobody will book a scooter with 499 rupees. Ola did a master tactics there. So what they did, with 499, pay now and book your scooter. But when it will reach? Maybe after 2 years. But now your cash flow, you have paid already 499 rupees. Think about 1 lakh customers from India paying 500 each, right? So that amount of money, 500 multiplied by 1 lakh, has gone 5 crores rupees of advance booking. 5 crore rupees of cash is lying with them. Use backorders as a jumping off point to expand production, right? So if it keeps happening, backorders keeps happening for next few months, few years. Now you have a plant manager actually have a point saying that, area you always come back to backorder. We have to increase our production capacity. We have to put a new assembly line, or we have to get into a new plant altogether, right? Gain market insights in advance, right? So different product, different type of backorder, different SKUs, right? So how many backorders are happening, right? It will give you insight for next forecasting also, right? Difficulties or problems, increased risk of cancelled order. Some items people will wait. People, like I said, certain customized vehicles, or let's say certain branded vehicles, people will not hesitate to wait for a few months. But it won't happen for all the items, right? If I need a cloth, if I need a bag, or I need certain food items, if I see that always I'm not able to find in my grocery shop, I'll move into the different brand, right? So remember which kind of product your company is producing. Is it a luxury product? Is it a branded product which people will wait for? Or is it a product where you have lot many competitors? If backorder is happening there, then there is a problem. You have to kind of improve your production capacity. Otherwise, your consumers or customers will move into different competitors. Payment processing headaches, right? Obviously, like you are taking money. Some people now, let's say out of 1 lakh customers, 30,000 or 20,000 customers, next quarter they'll cancel. Now you have to send back the money, right? So those are the again challenges. Increased customer service demand, same thing. When is my order? You had told that you will supply within 1 month. Ola scooter is actually facing that issue, right? So they had committed so many scooters. Now they are not able to meet the production capacity. Excess inventory advantages, if I see, right? Increase sale. Sometimes people keep excess inventory because they know that in holiday seasons, right now COVID happened, right? First, when COVID happened, the first wave, right? There is a lot of shortage of PPE, sanitizer, right? So now, because backorder happened, now they put much more quantity in production, right? Now some companies might have excess inventory, right? And they are waiting in case whichever wave happens, it will increase the sales that time, right? Wholesale pricing, this is basically for your raw material, right? Because whenever you are purchasing component, raw material, there might be a requirement that, okay, if you buy this much quantity or this much quintal, this much tons, I'll reduce my price by 10% or 5%. So that will be the deal with the procurement manager or strategic sourcing. Accordingly, they will bring that raw material, buy that raw material and keep in the storage space. Full shelves. So this is a psychological aspect, not true for all the items. Think about a showroom. If shelves are empty, you might have a customers might have a kind of get inside that, or might believe that your company might not be doing well, right? So sales need to show, right? But again, there is other way around it also, right? If you go to a Reliance Retail and Big Bazaar, and you always find that those products are already full, nobody is buying it. So look into which is your company old products, right? Or is it your you are selling that in a modern retail outlet, right? So psychology of customers matter. If you go to a Asian paint store, if you go to some paint store which have their own shop, right, specific dealer shop or distributor shop, when you search for it, paint is not there, right? Paint is not available, right? That gives a bad like trigger to the customer. Array, I think they're not in producing much. That company might not be doing well. Whenever I come, whenever I go, these products are not available. But in the similar way, if you go to a some place and you look into which are the if you're trying something new in a modern retail outlet, let's say you are trying for a t-shirt or some clothes, if you see that there are a lot of things flying around, you might be of the idea that nobody is buying this brand or nobody is buying this kind of items, right? Again, like this can be debated. What kind of what does full sales mean across different product categories, right? Handles uncertainty, like these kind of scenarios when there is a plant production shutdown, suddenly plant like COVID happened, now government has a regulation, you will not will operate in 50% workers. So that means you'll not able to operate 100%, you will not able to produce 100% quantity, right? So in this case, actually your excess inventory helps. Disadvantages, obviously tying up capital, your money is tied up. Inventory is always money, right? Whether it is raw material, work in progress, or finished good. If it is not being sold, mean it is just a wastage of money which is lying in your plant or warehouse. Increased storage cost. Obviously, if you're keeping inventory, you have to have that roof, you have to have a security person. So those are the storage costs. Obsolete inventory, right? So sometimes, like I said, MRO, all those maintenance you keep, and that is a big problem in bigger organizations, right? Without knowing how much inventory is there, they keep ordering and they keep storing, and items keep getting obsolete, right? So these are the few challenges of your excess inventory, right? Any questions on backorder or excess inventory? Okay, so if not, let me just quickly show you what assignment I have given you for next class. Okay, so this is the Excel file visible to all of you?
Yes, sir.
Yes, sir.
Okay, so this is around 50,000 rows are there, right? Don't worry about it. It is a easier task to do. Just you have to write certain Excel formulas. So let us start to understand. This is for FMCG company, which are these are nothing but the SKU numbers, right? So these are the numbers, identification number for a SKU, right? Let's say HUL. They are into so many products, so many SKUs, 5 gram, 10 gram, 30 gram. Each of them are the one SKU for a particular product. So these are the numbers. So this is the total national inventory for that item which is available, which is in the database, right? So that means for this SKU, I have 62 quantity of inventory. I do not have the price data, right? Or I do not have the data that what cost or what price I'm selling. That is a different analytics. What I want to understand, and I have sales forecast for next 6 months, sorry, 3 months, 6 months, and 9 months. And also I have a production forecast for 3 months, 6 months, 9 months, right? Now what I have to first understand, when I look into the month 3, whether there is a backorder issue. So when will the backorder issue will happen? So what did I tell you? Backorder happens when demand, right, is more than your supply or more than your inventory available. So I have a sales forecast. If this number is greater than my inventory number, right, it will get into backorder. If not, then obviously I have excess inventory at point 3 or month 3. Is this part clear or not? Anybody having any doubt on this? Backorder means what? Backorder means whenever you have more demand than supply or whatever inventory you have, right? So if my sales forecast is 0, let me show you wherever these are certain numbers are there. Put the filter. Think about this SKU, right? What has happened now? I have inventory of 1169. Sales forecast for next 3 months was 922, right? So what will happen on month 3? Will that be back order?
No, sir.
Sir, excess inventory.
Will
There
that
will
be
not be
a,
a back order.
so what you have to do here? You have to write excess inventory, yes here. So month 3, yes. So this is how you have to write a formula, because if you write manually, there are 50,000 line items. So you have to intelligently see what kind of formula you are writing, right? So what I want is in the question, if you go and read that question, let me read that for you. So you have to find out of those 50,000 row items, find out the top 50 items which has backorder issue. So how you find top 50, right? So those top 50 items quantity wise, right? Quantity wise, whichever the highest items, top 50. So you have to do a conditional formatting or a pivot table and find out those top 50 items which have a backorder issue, right? Then highlight the ones which are PPAP issue. PPAP is something is a production planning approval process. We'll not get into discussion of that, but know that what does it mean? Basically, any time any production starts, all those raw material component need to be approved by the strategic sourcing or the procurement manager. There is a quality process, right? So all those items, all those new items, old items need to be quality checked and said that yes, these are ready for production, like kind of. So that is what the meaning is: production part approval process. So these parts are ready for production. Okay. So whether there is a risk in that, right? If you see for certain products, certain SKUs, there is a PPAP risk. If there is a PPAP risk, ideally we should not produce anything. So highlight those, right? Highlight those out of those 50 top items which have this kind of yes, right? Then look into something. We'll look into the back order thing, right? We have looked into excess inventory where back order will happen. So think about this thing, row number 568. I have inventory of 261, right? I have a sales forecast of 362. What does it mean? I have only inventory of 261. So on month 3, when I look into my forecast, my item is 362. That is a forecast of 362. Assuming all these numbers are correct. So how much quantity of back order will happen? Month 3. So if I have a inventory of 261,
Sir, 101.
101 here, right? Went to back order on month 3 and quantity is 101, right? Then what about month 6? Went to back order on month 6. Whether it will be true or not. How will I do that?
Sir, 126 back order.
So
On
how will you
months.
calculate? So first you will see, okay, what is my inventory? What is my production? Whether I'm going to produce or not. Look into the next example, row number 644. So I have a inventory of 7, right? And I'm going to produce, sorry, my sales forecast is 9. So on month 3, what happens? 9 minus 7. So there is a 7 minus 9. That means there is a minus 2, back order of minus 2. Then what happens? On production forecast for month 3 is 7. So then I produce 7 more, right? So my inventory will be how much? Minus 2 plus 7 becomes 5 again, right? But again, I have a forecast of 20. Then that minus 20. Then again in my next 6 months, what will be my back order? Whatever my inventory after production minus sales forecast, that will give me the back order at month 6. Similarly for month 9, right? So you have to calculate intelligently, knowing for which month, which forecast you are calculating. Is this clear or any doubt?
Sir, can you please repeat one?
Okay, take this example, right? Row number 644, right? So what I told, what do you mean by backorder? Backorder is when there is more demand than your supply, right? So on this inventory, you have 7 only, right? So for when I'm looking into next 3 months, I have 7 in inventory. Then how much is my sales forecast? Is 9, right? Then what will happen? I have a back order of -2, right? That means
Yes,
there is
sir.
2 items are there which I'm not able to meet. So here you will put -2. There is a back order. That means whatever you put -2 and say that. So what if you put a number here means there is a back order. If it is blank, that means it is not. There is no back order. If I go to month 6, what has happened? So I had 7 -2 as inventory. I produced 7 because production forecast within that 3 months is 7. So -2 plus 7. Now my inventory, new inventory at the month end of 6 is how much? -2 plus 7 is 5, right? But what is my forecast for next 6 months? 20. So 5 minus 20 is 15, -15, right? So that will be here.
Okay, sir.
Then you have to again do it for, so again, like it is not manually, you put those minus plus formula. So in Excel, it will be automatically calculated.
Okay.
Okay. Similarly, for the excess inventory, where you have a kind of inventory and you do not have any sales forecast, right? So here, if you see 2860 is inventory, then sales forecast is 550. That means here you will have excess inventory. 2860 minus 550. This is the excess inventory in 3 months. Then in the next 6 months, actually it will get into back order. Why? Because you will have how much inventory left? 2860 minus 550 is 2310, right? But you have a demand of 2550. So you'll get into it 6 months, you will get into back order because there is no production forecast, right? So accordingly, you put a formula, right? You put formula for only one row, then drag it for 50,000. You'll, so only difficult part is to understand which will be plus, which will be minus at what point of time, right? So that is for your class exercise. We'll stop here for today. I think there are 3-4 slides more. We'll discuss that in the next class. Okay. Any questions or any doubt before we close? I'll send the slides, go through it, and if there's up any doubt, we'll discuss again in the next class. Okay. So if not, I'm closing the session.